Hello everyone. Hi. So today we are solving another interesting problem. Number 1157, minimum number of vertices to reach all nodes. And the problem says given a directed acyclic graph with n vertices numbered from 0 to n1 and an array edges where edges of I is equals to from of I to 2 of I represents a directed edge from I to node 2I. Find the smallest set of vertices from which all nodes in the graph are reachable. It is guaranteed that there exists a unique solution. Notice that you can return the vertices in on any order. Okay. So we have been given one graph and it is a DAG, directed acyclic graph, which is good. And we need to find the smallest set of vertices from which all nodes in the graph are reachable. So just by the looking at the graph we can see we can reach 1 and 2 from 0, okay, and we can reach 2 from 4, and we can reach 5 from 2, and we can reach 4 from 3. Okay, so 0 and 3 because we can reach all the nodes from all the nodes 1 2 4 and 5 from the node 0 and 3. Okay, so to solve this problem what I will do is I will create one in degree meaning number of incoming edges to a node. So if this is ith node and there are 3 incoming edges, so in degree is 3, and out degree means number of outgoing edges from a given node. So if it leaves from this, for this example this is j, then out degree of j is 3. Okay, so to solve this problem what I will do is I will create one in degree map where I will collect every item, every node in degree value. So that would look something like this. So as I'm traversing I will see that for 1 could be reached from one way, 2 could be reached from 0 by one way, similarly 5 could be reached from 2, so 5 would be 1, and simultaneously I need one node to see that how many nodes that I have visited. So I visited 0, I have visited 1, I have visited 2, I have visited 5. Now for 3 and 4, 4 I have visited once, so 4 I will also add, and 3 and 4 both will also be added in my node set. Okay, and lastly 4 and 2, so 2 has already come once, so 2 will increment the 2 by 1. Okay, now we'll see in our node set how many has in degrees which are not be reachable. So we can see there is no 0 and there is no 3, so we need to find, so we'll add these from our into answer list and we'll just return this. So these are the number of smallest set of vertices from which all nodes are reachable. So for 0 and 3 I will look in the in degree map and I will check if in degree of this node, for which node the in degree is 0, and I will just collect those elements. Okay, so yeah, here is how we can write this problem. So I'll define one in degree hash map. It would be a default dictionary of integers, and as we'll traverse from start and end in edges, we'll add the incoming edges into a node by one, and we'll also create one node set that we discussed to keep a track of all the nodes that we have visited. So we'll add these nodes dot add as, and we'll add the also the outgoing, from incoming to outgoing. We'll also add the edge, and now just we need to look into our nodes for which node my in degree is 0, and the nodes for which in degree is 0, I will just collect that into one list, and that is what we are going to return. And we'll return this answer list that we have created now. Okay, so let's run our solution and see how it performs. Okay, so now let's run it for different edge cases. And let's try submitting our solution and see how does it perform. Okay, so it has been accepted and it is running perfectly, and the time complexity for this problem would be O of number of edges that we have seen in the problem. So number of edges, so for this one we have 1 2 3 4 5, so that is the time complexity. And since we have added all the edges into all the nodes into our set, so that space complexity would be O of n, where n is the given n. I don't know why they have given this n, it is useless. Okay, so that's how you solve this problem. Thank you.